Good morning, Honors Algebra 2. So today we're going to talk about section 12.8, solving general triangles. And I hope you've already watched the video on the ambiguous case, the SSA triangle. If you haven't done that, go out of this video and go back and look at that. It's posted right above this video under today's lesson. So let's go ahead and talk about solving any triangle, solving for any side that's missing, any angle that's missing. Okay, the first case we have is the SSS case, where we're given three sides of the triangle. And we remember that that is the law of cosines, the law of cosines. So you can solve for any angle you want to solve for first. You've got to solve for all three. Okay, and once we solve for 2, we can subtract the sum of those two from 180 to find the third one. So we just have to do 2 different computations to find the 2 angles that are missing. So law of cosines is a little bit more tedious, and so I don't use it unless I really have to, and we really have to right here. So I'm going to go ahead and solve for angle A. Okay, so if I'm going to solve for angle A, I'm going to use the equation a squared equals b squared plus c squared minus 2bc cosine A. And if I rearrange this formula, I'm going to bring the negative 2bc cosine A to the left side, bring the a squared over here, and subtract it from b squared plus c squared, and then divide by the coefficient 2bc to isolate the cosine of A. Once I do that, I just fill in my numbers. Remember, B is across from angle B, C is across from angle C, and I get that the cosine of A is approximately 0.75. Use the complete number that is in your calculator when you do this. Now, if the ratio is 0.75, to find the angle, remember we're going to use the inverse cosine key, and the inverse cosine of 0.75 is 41.4 degrees. So let's go ahead and put 41.4 degrees in for angle A. 41.4 degrees. Now, what's wonderful is we now have an angle and its opposite side. So what do we do next? We go over to our easier equation, the law of sines. And so now I can do the sine of 41.4 over side A, which is 4, is equal to, and doesn't matter which one, I'm going to go ahead and solve for angle C. The sine of angle C over 5 is on the other side of the proportion. And now I just cross multiply. I isolate sine angle C, and I go ahead and compute and see what this is. And that is approximately 0.8266, and then I can take the inverse sine of that ratio to find the angle. And so now I have angle C. Let's go ahead and box that. Is 55.8. Angle A is 41.4. And then, of course, to find angle B, I don't even have the work up here, but you will add these 2 angles together and subtract their sum from 180 to find the remaining angle B. All right, so on SSS, we used our law of cosines necessary to do that, and then we switched over to the law of sines to find the other 2 angles. Now, let's go to the second case, the SAS. Well, you know, SSS and SAS are both used with the law of cosines. So once again, what are we given? We're given angle A has a length, side A has a length of 8, side C has a length of 7, and angle B is 31.8 degrees. So I just did a simple sketch here. You don't have to do a sketch, but what I know is I have 2 sides and the included angle. If you have an A, a C, and then the remaining angle has the B, you've got ABC, 2 sides, included angle, ABC. All right, now I've got to use the law of cosines again. And since I know angle B is 31.8, I'm going to solve for side B. And so I'm going to use this law of cosines equation, fill in my values. Remember, this is b squared is equal to this value. And so you've got to take the square root to get the answer, and B is 4.2. All righty. Well, if B is 4.2, I'm going to go ahead and put that over there. Then now, again, I have an angle and its opposite side. So I'm now going to revert to the law of sines, which will give me the sine of 31.8 degrees over 4.2 equals It doesn't matter if you solve for C or A. I went for C equals the sine of C over 7. And once I go ahead and do that, I can solve for the sine of C and then do the inverse sine to find the angle. And then I've got a second angle. Now that I have a second angle, I can just add those two together, subtract from 180 to get my third angle. So this, I didn't finish this up, but this is actually, a problem from the book. So you can go ahead and see the end result there, but I think you understand where this is going. Now, let's go to the other side, and let's look at our last two situations here. I'm saving the hardest for last. Okay, the AAS. All right, I have two angles and a non-included, well, two angles and I do not have the side between them. So anytime I have two angles and then some side, I know right away I can solve for the missing angle by just adding the two I know and subtracting from 180. So now I know that angle B is 80 degrees. Angle B is 80 degrees. I'll go ahead and put that in there. If angle B is 80 degrees, now what I have here is the law of sines. I was given an angle and its opposite side length. Boom, law of sines. So I got the sine of 45 over 40 equals the sine of, I'm going to go ahead and solve for, let's finish the side C. I'm going to solve for side C equals the sine of 55 over C, and I will get that side. And then to get side B, I'm going to have to go ahead and go back, and I usually use a pair that I'm given. If I can, I use what's definitely given by the book in case I make an error. So I'm going to go back and use the sine of 45 degrees over 40 again is equal now to the sine of 80 degrees, my B angle, over side B. And I can solve for my two sides. That was really straightforward. Okay, law of sines all the way. Okay, I hope you watched your video on the SSA case, the ambiguous case. And I put a frowny face because this is a pain in the SSA. Oh, yes, it is. Now, I'm given side B, side C, and I'm given angle B. Now, when is it an ambiguous case? When this angle is acute and when this angle's opposite side is less than the other side given. 22 is less than 30. Okay, so I'm given angle B. Its opposite side is shorter than its adjacent side. And so therefore, I have this little swinging arm scenario, which you saw on the other video, which I thought was a really great video, cool video, and I hope you liked it. I thought it was pretty awesome. Okay, now with that, I know that I have two different triangles. So I have two options. Option one, I just go ahead and do the law of sines. I've got 30 degrees. I've got its opposite side is 22. The sine of 30 over 22 is the sine of C over 30. With my calculator, I get angle C to be the acute angle, 43.0 degrees. If this is our triangle, and this is 43 degrees, and this is 30 degrees, I can find angle A by adding B and C together and subtracting it from 180. So here I have A is actually going to be 107 degrees. So this angle here with this option, with C being acute, is 107 degrees. If that's the case, I can use my law of sines now. The sine of 30 over 22 is going to be, the only other thing I need down here is going to be, side A is going to be the sine of 107 over A. And I get A to be 42.1 degrees. So here is my first scenario. I've solved for the missing two angles, and I've solved for the one missing side. Now, the other option would be if angle C were not this angle, but we swing that side inward, and we're going to have the supplement of 43 degrees. This is 43 degrees. This is the supplement of 43 degrees. So we're going to have an obtuse angle. So it's going to be 180 minus 43 degrees, okay? So this was the first option we got with our calculator. The second option is angle C being right here, and it would be 137 degrees. If that's the case, then angle A is going to be the sum of 137 and 30 is subtracted from 180, and angle A is only 13 degrees, okay? So now we've got an acute angle for A, and we've got an obtuse angle for C. And so now what I'm going to do is I'm going to go back and use my same ratio. I have 30 degrees and 22. So the sine of 30 over 22 is equal to, now angle A is 13, the second scenario, over side A, and side A is 9.90, 9.90 instead of it being 42.1. Of course, A is this length. It's going to be shorter with this scenario. It's going to be longer with this scenario. Okay, so that is our lesson for today. And so what you're going to do is you're actually going to work out of your book today, and then you're going to check your problems in the back of the book. You're welcome to use Slater for steps. And then I am having a Zoom meeting. In fact, let me write that up here in the corner. I forgot to write that down. I'm going to have a Zoom meeting today, and I'll post it in the morning at 9 a.m. And it's just a link that you can put in your browser, and you can join our meeting. If you don't have Zoom on your computer already, when you try to join the meeting by clicking the link, it'll ask you to download the program in order to join the meeting. Okay, and our meeting starts at 10 o'clock a.m. This is purely optional, It's just to get homework help. So my recommendation to you is, since our meeting is at 10 a.m., what I want you to do is, if you don't mind, do your math homework first in the morning. Okay, do it first, and so then at 10 o'clock, you'll be ready to go asking questions. And I'll be here to work out questions with you. Purely optional. I'm not sure if I said that or not, but it is. And so I may have one person, I may have all 13 of you, but I'll see some of you later this morning. If not, I'll be back with another lecture tomorrow, and we'll finish up our chapter. All right, y'all have a great rest of the day. I miss you. Bye-bye.